Okay, we will start with take-home exam. Question answer for 10 minutes. Okay. Last 5 minutes, we will do quiz. Alright. So question from Victor, what's your question?
Okay. The equation 4.15.
Equation 4.15.
Yes, it's for the condition for which we have bubble regime.
Okay.
So
Rho square GD square over delta rho sigma everything to power of 0.25.
So they in the book they mentioned that 5 centimeters above that you
Okay.
will have bubble, but for that value, the 4.36. If we use the properties that we were working with,
Okay.
in that case it's 4.30. So
If you don't have the transition E, you should prove that you don't have transition E. If you have transition E, you plot it.
okay. The thing is that what I did was I used the 5 centimeters to recalculate the value, and I put the code 4.26. So in order to have all the
Do you have transition E or you don't?
No. It's because it's expected to have for the pi diameter that we have. But I think it's because of
You're not the
the
one who
properties.
decide. You're the one who decide. It's not about I want to have it, so I adjust it a little bit. Based on the available model, what is the line?
Even with the Excel file,
Uh-huh.
they have the same issue. Like if we use the properties that we are working with at that diameter, we are not going to have that.
Show the proof that you don't have you don't have transition E is not always. Sometimes you have, sometimes you don't. Okay. If you have, draw it. If you don't, show the proof.
Okay.
Next question. No more question? Question from me. Oh. Yes, Yash. What's your question? Isaac. How much you complete for the take-home exam?
Oh. I want the last one.
What is that?
Transition E something?
So take-home exam, you done the last. The part that have like
That's blue.
the pressure drop part, did you do that?
Yeah.
That is long.
Yeah, it's super long.
Oh, that's why it's take-home exam.
Question?
Oh, slab flow, horizontal? Near horizontal?
Yeah.
What is superficial velocity? What is Renault number of the slab body? More than 2100? 100, so it's turbulent. This one here too? So that equation.
Yeah, and for this one,
This is different.
the same one.
That's my point. It's not the same.
Exactly. That's
It's
what
not the same for VS, for VTSL. C0 over there
It's more.
and C0 over there.
It's different.
It's not the same. Got it? Okay, let me borrow this.
How about the error?
What
Because
was that? All right. So which task worth how many points?
Is that? Which
Do
one?
I show it over here?
Josh, can you help me?
no, it's
What's this? Okay. Task 1, just 8%. 1.1 is just X%. 1.2 is just 2%. Okay? 1.3 is 18. Right? So that's a lot. And how much is for test 2? Test 2 is just 2%. Okay? And you should do everything. So 1.3, why should it be a lot? Because you're gonna do Shaw model, right? Who haven't tried this yet? Isaac, did you do anything with this 1.3?
Yeah.
How much did you complete?
Like, oh.
100%. Congratulations.
But it's just long, that's all.
Alright. What about you? How many percent? You haven't started? I'm talking about 1.3. Oh, you are in danger. You are in danger. Yes? You finished? 1.3? Okay. Did you have confidence in your answer?
I have confidence with like the air.
Do you know that the file uploaded on Blackboard is from Shoham textbook? And in that file, there are 2 programs. Program number 1 is to do the flow pattern. Program number 2, which is just exe file. And it's a little bit more complicated how to run it. And I don't talk anything about it in the class, but it's discussed in the book. That is to get pressure drop. Okay, but that pressure drop is not going to be as good as your pressure drop. Okay, because your pressure drop is more accurate. You consider the film profile, everything, right? Victor, you did 1.3?
Yeah, but now they
Complete?
I completed, but I followed the Shaw and all model.
Okay. Shall didn't have the film profile, right? Alright. What answer did you get? Good answer?
The only thing that I'm not confident is about the stratify because
Alright, guys. If you don't have confidence, how
Sometimes you
when you do this kind of thing, you are the first observer who get the result. No one get the result. Even if you try to compare, you are not allowed to compare with your classmate. But even if you do that, you don't know if his is wrong or you are wrong or both are wrong, or one of you are correct or both correct. You never know. The one thing that you can do is to check the order of magnitude of your answer. For example, when you do slug flow, okay, there's a film part and there's a slug part, right? In the film part, what is VSL, VSG in the film part? In the film part is follow stratifying model, right? Okay. So how much do you get in the film part? That can be compared to the case of stratified flow with the same height or the same VSL VSG. The VSL VSG that I'm talking about is just in the film part. But for in the bubble part or in the slug body part, that's equivalent to dispersed bubble flow, right? How much is the pressure drop per unit length that you have from there and dispersed bubble flow? So when you have horizontal flow, do you have horizontal flow cases? And some other case, right? When you have horizontal flow case, there's no hydrostatic head part, right?
Yeah.
Okay. So is your answer far away from single phase flow? Or same order of magnitude? It should not be the same. But if single phase flow, you get 100 psi, 100 pascal per meter. And slug flow, you have 10,000 or something. There's something wrong. See what I'm saying? So you never know that it's correct or not, but you can check if it is wrong or not.
For the stratified maybe they would have had a problem.
You have a problem? Somehow,
The structure.
Chow et al. Did not have the problem. You want to give them a call?
No. When I compare the data pressure drop.
It's not the same.
Not the same.
And the reason that it's not the same is, you know why it's not the same if you use it? It should be the same, right? If it is not the same, that is because you did it wrong. Very clear, right? What I'm telling you is that F sub I
Yeah.
that you get come from H tilde. That H tilde does not satisfy both gas phase equation and liquid phase equation at the same time. That because your H tilde come from approximation.
Is that?
So the approximation is okay. If you read the textbook, it's okay to do flow pattern prediction. But once you try to do pressure drop, you got to have the value of height that satisfy both equations, so that when you substitute F sub I in the visual friction factor, whether you use gas equation or liquid equation, it satisfies both.
Yes, sir.
You
For
understand?
example, in that case, we use the rigorous way to calculate it.
Uh-huh.
But I did that, this is still not the same.
Ah.
That's not
My
sufficient.
question is
When it's not
about-
the same, this means the height that you got doesn't satisfy both equations at the same time. They satisfy just one, but not two.
The gas, and is the gas giving much more reasonable pressure drop answers than the liquid?
Oh,
The liquid is-
they both, theoretically, both of them has to be the same. You are about to derive the combined momentum equation, right? That equation is without assumption. The question is, with your tau sub I and H tilde that you got, does it satisfy that equation? If it doesn't, is depend on how much it's off. If it's a lot different, it's wrong. If it's close, it could be numerical error. You can discuss that in your result. But if you haven't done anything yet,
But the thing,
be quick.
but the thing is, for some condition, for some superficial velocity, it was similar, but with other ones, it's
Why is that? Tell me something. If you do everything just fine, you don't have to tell me anything. But if you do, hey, liquid equation equal to 0, gas equation left hand side is not equal to 0, but right hand side should be 0, then you have to explain me something. Why is that? I can just say, okay, this student actually they know about theory. There could be something in the code. I scan the code. Okay, it looks reasonable. I just give the point. Or this student don't understand anything. It's just wrong. Just give them 0. Yes. How much time did you spend on this take-home exam? How many hours? 5 hours. 5 hours. Are you serious? 5 or 50? I cancel. No, I didn't cancel. I replaced the class time with take-home exam time. And I didn't give you any additional homework, right? How many hours did you spend on this? Yes. 50?
maybe.
Could be 50 hours.
More than 50.
How many hours did you spend? 70?
Almost like, yeah.
About 70. How about you?
I'm still working on it.
How about you, Victor? How many hours?
Maybe between 12 and 15.
12 to 15 hours. Okay. Do you get it done? Not yet, almost?
Okay, now I need to change the last part.
So if I don't know anything, I can say, okay, you get 0. You get 5. You get what, 50, you get 15. You get whatever number of hours that you spend on. But I know that some people get it done quick. Maybe you're 5 hours, everything correct. I don't know. I don't look at it. But I want to give you some idea. How much is the difference between graduate school and undergraduate school? It's not the same. Okay? And this kind of thing worked 2 years ago, 4 years ago. Last 2 sessions that they take Multiphase flow, they did something else. But I can tell you this, the degree of difficulty is equivalent. Okay? They earn it, you earn it too. And maybe you want to do 50 hours, 70 hours like that. He may not did much, 15 hours. Did you get it done? Probably. Okay, any other question? Yes.
I use Excel to calculate Excel.
Okay.
And after doing that, then I compare it with the distribution Excel equals AL over AP. Doesn't match.
Doesn't match. Your Excel worksheet is has some inconsistency.
How can I solve?
Do you use VBA a little bit to write function?
I use for the code.
Function is somewhat long. If you write your function in VBA part, it will be easier, a little bit easier. Okay. There's nothing wrong if you do it, and it's not like AP is a little bit. The first step, if you want to know, okay, you check each equation, but that's almost impossible. So what you can do is, hey, if my HL tilde equal to 0.5, will AP be double of AL? Will it say that? Did you check it?
I check it like every question as well.
Oh, not enough. Typically, okay, coding time is 1/3. You know what do you do another 2/3? Debugging. Okay? So if you make it, okay, you are in the right track. But if you haven't done it yet, I strongly encourage you to get it done until your performance match with your peer performance. It doesn't mean that if you do 70 hours like him, you get like what he got. Maybe you get more. Alright?
I got the same profile as like the same chart.
Okay, when you get the chart, you compare with the result in the program. Are they the same? Identical?
No, yeah.
It should not. Is it identical?
No, it's not.
No, it's not. Whose is? Which one is correct? Yours is correct. Do you know why yours is correct? You take it at the face value. It is what you put it in. For the source code that you have, you don't know what is inside. It's maybe more accurate. You don't know because that's an exe file, right? So your case is correct with the support. The support of your calculation is your source code.
Yeah, that's what I'm saying. Like it's correct, but though the HL value doesn't match.
HL value doesn't match.
Yeah, like.
Okay. In some of the homework, I have the S-curve shape. H tilde with X and Y. You remember that? I'm talking about 3.34 or something. You remember this?
Yeah.
So, if you do turbulent liquid, turbulent gas, can you match with this? Okay? Alright? If you substitute it in the combined momentum equation, does it work? Does it give you 0? So it's correct. Or maybe you have to go over it a little bit. When you study it in class, do the homework. It's not the same as this take-home exam, right? It's different. This one is the real one. I think we a little bit over time, but okay. I hope you get some idea on what was the deadline again? November 6th. Am I going to extend it? I don't, because last year Student complain when I extend it. One student say, I give up everything to just do your exam or your homework, your take-home exam. Other people didn't give up that exam, but when the time comes, I extend it. So they have, it's not fair for him or something. So I don't. Okay?
How about the error? I mean, he has some error.
Do your best.
Yeah.
If it doesn't match, explain why. Okay? As much as you can. This is not something that complicated, not rocket science. No, it's just follow whatever step that they did. Right? It's not that easy. You may see it right now. I hope you realize. Let's continue. Last time we talked about every equation for transition, but we didn't talk about derivation, right? One big thing that we skip is about transition H. Okay? Transition E, the existence of transition E, we talked about it already. Transition F and transition G, we talked about it already, right? I plan on, like next time, I may have every equation is correct. Like, you see this equation? Okay, that equation, the equation for transition F, transition G, I plan to have every equation correct. And I plan to show you this graph. And I ask you, which equation is for what graph? Okay? I hope you get 10. Maybe except Isaac, because he's not here. And I don't think he's gonna watch the video or anything. Don't give him that, okay? So I give you equation F, equation G, equation J, equation H, equation E. It's just equation. And maybe the existence of equation E equation. And maybe a couple more equations for transition A, B, C, D or something to confuse you a little bit. And I ask you, which line is for equation, which equation is for that line, equation F, line F, which equation is for transition G or something, okay? And I hope your due diligence, coming to class on time and stay here the whole time will make you something, compared to the person who just, yeah, let me go out and do something else. Alright, let's talk about transition H. The mathematical part. Okay? This is a picture that we talked about it last time. The reason that we have churn flow is two Taylor bubble doesn't move at the same speed. Taylor bubble 2 on the bottom one move faster than Taylor bubble 1. When it moves faster, it merge. Right? The question is, how many times that it has to merge until we get a stable slot? Stable slot means this length is 16 diameter. So we have to do some math. Alright? So this part we talk about it a little bit, right? The z direction is downward. Okay? Z equal to 0. Velocity is VTB. Why is that? VC, center line velocity, equal to VTB. Why is that? Come on. Okay, maybe you have some other great exam. Okay, yes, why is that? VC is center line velocity. Why VC should be equal to VTB? Victor.
Because that's the velocity of the boundary,
Interface. The bubble, interestingly, the bubble moves at the speed of what? VTB, right? So, at that part, the center line velocity equal to VTB. What about over there? You see that thing? Z equal to Ls, Vc equal to 1.2 Vm. Why is not VTB? Because we are not talking about the velocity inside the liquid phase. We're not talking about the velocity of the interface, but we're talking about the velocity in liquid phase. Okay. If you recall for horizontal flow, velocity in the film zone, when you look in the lab, okay, in theory everything equal to Vm, right? But when you look in the lab, in the front it's kind of a little bit faster or something. The interface moves slower. So right at the back of the bubble, right at that point, is the interface velocity. But inside is kind of liquid phase velocity. And at that point, I say, okay, Vc equal to 1.2 Vm. Okay? Liquid at the end of the slug body moves slower than VTB. Okay? So liquid exactly at the front of slug move at the tailor bubble speed. So it's not the same. And let's see about exponential decay. Okay. We assume something instead of linear, we assume exponential decay of the velocity profile. Look at this equation. Okay. When you see this equation, we see centerline velocity, right? Centerline velocity is the kind of linear combination. We have this term multiplied by some ratio, and this term multiplied by another ratio. Okay? The first term is velocity is z equal to 0. The second one is velocity is z equal to Ls. You see something here? So it's a weighted average. The velocity inside at the center line is a weighted average. But we didn't do like linear. Okay. If we do like linear interpolation, it's going to be what? If we do linear interpolation, instead of this term, I just say, hey, z over Ls. And this term will be 1 minus z over Ls. So if I do it like that, it will be linear interpolation. Right? Linear interpolation means, okay, z equal to 0. Oh, then I did something wrong. I think I have to do 1 minus over here and over here without 1 minus. Okay. If z equal to 0, this term go to 0, and we have just Vc equal to z at 0, or something like that. This time instead of linear. Title, come up with other way to do interpolation. They call it exponential decay. Alright? So it's a combination weighted average, but the weight is kind of exponential function. Okay? Look at this. Z equal to 0, exp of 0 is 1. Right? So this term will be 1. Alright? This term will be 1. 1 minus 1 is 0. So at z equal to 0, Vc equal to Vc at z equal to 0. Correct, right? And V equal to Ls. If you put Ls over there, is exp minus beta. Vc at z equal to Ls multiplied by 1 minus exp to the power of minus beta. What's beta? Beta is kind of a constant sitting there, and in this case we select natural log of 100, and you will see the reason in a moment. Okay? We cannot have 0. Exponential of something cannot be 0 unless it's exponential exp of minus infinity. If you have exp of minus infinity, it will be 0, right? But you cannot write minus infinity over there. Instead of minus, it depends on what are we looking at. How small is small enough? In this case, if it is dropped to 1%, we are fine. 1% means what? At z equal to Ls, V will be 1 over 100 of Vc at z equal to 0 plus 0.99 multiplied by that. Provided that you set beta equal to natural log of 100. If you use beta equal to natural log of 1000, you will have like 0.999 of Vc at z equal to Ls and 0.001 of Vc at z equal to 0, right? In this case, they say, okay, 99% is okay. When velocity change, 99% and 1% from that point is okay for this kind of linear combination. It's an assumption, okay? Got it? And there's a good reason that they assume like that. Because in nature, it's not quite like linear. It's kind of more like exponential. If you want to know what is the difference between linear combination and exponential combination, is it like that line versus that, or versus that, or what exactly it is, or it's like this? You have to plot it. Okay? Show it to yourself. Analogous form for linear decay is this form. When we talk about it, right? So this term go there. So that's analogous form. All right. With this equation, velocity, we substitute the value. Okay. Vc at z equal to 0. I put that, which is from previous slide. Okay. Vz at z equal to Ls, I put that 1.2 Vm. Where does it come from? Previous slide. 1.2 Vm. Now substitute the value. Oh, wait. Where does that come from? Yes. Where does that come from? Whose closure relationship? Start with B. Ben something. Ben Dixon. You agree, Isaac? Okay. So basically we just put the Ben Dixon closure relationship. Put theta equal to 90 degrees. Right? And that term stay. Do the math, combine it, because that term they can combine, right? Combine it, we get that. So this equation tells me velocity at any location inside the slug body for the case of 90 degree upward flow. Good? Alright. So next step, right? We try to look for the case of the length itself. You see this stable slug, unstable slug. Okay. I put here that if it is sufficiently long, what is sufficiently long? That part is sufficiently long. Vc will be equal to 1.2 Vm, and VTB is not faster than usual. So this means if we get stable slug, whenever we get stable slug, both bubble move at the same speed. That's what it is, right? If it's unstable, the bubble in the bottom move faster. But if you have long enough slug length, both bubbles have the same speed. You got the idea? So the question is, hey, what is the length that require to have both bubbles move at the same speed? Experimentally, it's 16 diameter, right? So if the slug length is long enough, okay, you see this one, this equation, okay. Slug length between tail of bubble will be that. VTB2, okay, is center velocity and bubble 2 plus a little bit of drift velocity, right? That's VTB2. Okay. All right. You see this one? VTB equal to 1.2 Vm plus 0.35 square root GD. That is what's that? Come from VTB1, right? VTB1. This term is VTB1. Now let's take a look at this equation. What is VTB2? VTB2 is center line velocity plus a little bit of drift velocity. You agree? Center line velocity plus a little bit of drift velocity. Okay. What is center line velocity? Center line velocity is this equation, right? When we do the math, that's the center line velocity. It's not just center line velocity, it's center line velocity at any length, at the length of z. It's the center line velocity at the length of z. So if z is more, okay, this term will be kind of less. If z is or something like that, because this is minus sign, right? Okay, whatever it is, this is center line velocity. Tail of bubble number 2, I put center line velocity in there, just substitute it in there, and have that term over there. Okay, now we know VTB number 2. Alright? Any question yet? Not yet. Let's take a look at the shrink rate. Shrink rate, what was shrink rate? Shrink rate here is the rate of shrinkage of the slug length. They call it minus dTdz. That's the shrink rate. Okay. So z is what? Distance, right? Derivative of distance over time give me velocity. Make sense? So shrink rate is this length versus time. Okay. I have minus sign over there because it's shrink rate. When time go up, z go down, right? So because number 2 move faster than number 1, when time go up, number 2 move faster than number 1, and the distance between 2 bubbles is less, right? That's why we call shrink rate. So dz dt is positive or negative? Yes. dz by dt itself, not minus sign. dz by dt itself is negative or positive? Negative. Because z keeps shortening and shortening and shortening because bubble 2 move faster than bubble 1. Okay? We put minus sign over there so that it becomes positive. And look at the right hand side. Left hand side is positive and now right hand side is positive because VTB2 is more than VTB1. That's why it shrinks, right? Make sense? Okay, so it's delta VTB. We do the math. Okay, we have VTB2, we have VTB1,
VTB1 is just that. So VTB2 minus VTB1, I get that term, cancel with that term, 1.2 Vm, cancel with 1.2 Vm. That's the rest, or whatever it over here. Good? Now we have the shrink rate. Is it boring? Yeah, a little bit. Are you going to use it? Maybe not. Okay. But when will you use it? Other model of yourself when you do research. Okay? Should we discuss it during undergrad class? No. But PhD class, master class? Yes. Alright, so bear with me a little bit. We have shrink rate over there. You see that? Alright. So this is the equation. Right? That's the shrink rate. As Z decrease, shrink rate increase. Do you agree? Mathematically. So Z equal to 0 is like 1. Right? Z equal to infinity is like 0. So yeah, as length decrease, shrink rate go up. So this means if you start to bubble very close, it shrinks very quick. If you start with two bubbles far apart, it shrinks slowly. Okay? Got it? The slug body shrink from L sub Li to 0 for slug to be blown through. So when we start with Li is like initial length. Wait for a little bit. The length will shrink and Z will be 0, right? So this is because bubble 2 will move faster than bubble 1. Got it? So it starts with Li, and after a while it becomes 0. We will move dt to this side. Okay? Right now we get this equation. I kind of separate the variable before I do integration. I put this whole thing on the denominator because this is a function of z, right? And put the integration limit. At time equal to 0, the distance between two bubbles is L sub Li. At time equal to some time Ti, the distance between two bubbles is 0 or it reach each other. Now I start the integration limit. Time equal to 0, okay, and Li, so I put over there, and that's over there. Because at time equal to 0, L at Z equal to L sub Li. At time equal to T sub I, Z equal to 0. You can switch, but when you switch both sides, it's the same. See what I'm saying? Alright. Now is the time to do integration. Okay, integration of exponential function. A little bit of calculus 1. Okay, instead of beta, I put beta ls inside. I take this thing out. Okay, change the limit of integration. Multiply by this, so it's the same. Integration of exponential, get the same thing. So I get t sub I like that. Good? Okay. How? What is t sub I? What is the meaning of t sub I?
The time required for the two fill bubble before you get to try.
Very good. I like your answer.